The problem is to sum 2 input array sorted. So what you're trying to do is you have an array of numbers, which, like I just said, are sorted. You have a target number. What you want to do is find 2 elements that add up to this target number. I believe they want the indices. Yeah, they want the indices, whatever. They want it one index instead of 0. I don't know why, but it doesn't matter. And they also want the solution to be constant extra space. Now, these two sum problems, like the original one where it's not sorted, you can solve it in O of n space by creating a hash map where I believe the key. So what you would do, I don't know why I'm outlining this, but let's just run with it. What you would do is you'd say, okay, for each number, you'd take the total. You say 2 minus the given number, so 2 minus -2 equals 4. And you say, okay, hash map 4 equals, we'll throw the index as the value. So the hash map looks like the key of essentially the number you need to add to the current number to equal the total. So that's the key, and then the value is the index of the number you use to get this value. So it looks like this, right? And each time you check a number, you say, okay, is this number a key in the hash? No, it's not. Okay, so we'd say total minus the given number, 2 plus 1, 3. Again, the key is that value there. The difference really is what it is. A little confusing with negative numbers, but then the value is the index of the current number. So repeat that process. Say, okay, is this number in the hash? No. So we say 2 minus 2 equals 0. We'd say, okay, 0, 2. Okay, 3. We'd say 2 minus 3 equals -1. Is that in there? No. Or I guess rather, if you want to check here first, I missed it. You want to check, is 3 in the hash? Yes, it is. Okay, that means we can get our sum by taking the guy at index 1, so -1, plus the current guy equals just 2. That's the total. So we'd return the value here, 1, and the value here, the index, 3. And then in the problem, they wanted one index for whatever reason. The problem is, with this problem, we don't want to have this hash. We don't want to use this because that takes space. Now, this might seem like a really hard problem, but the fact that it's sorted, right? They're very clear about that. It's sorted. It's in the title. That means it's going to be useful for solving the problem. So the way to do this is use 2 pointers, right? We put a point on each end of the array. Now, so because it's sorted, this pointer over here starts pointing to the largest item in the array. So the more you go to the left, the smaller the number gets, no matter what. Well, technically not no matter what. You could technically have like 2 or 3 of the same number, but still, you won't get bigger. You'll either stay the same or you'll get smaller. And with this one, it's the opposite. You'll either stay the same or you'll get bigger. So what you can do is use that information and say, okay, we start by adding the numbers at the 2 pointers. So -2 plus 5 is 3. Is that number equal to that? No. Is it greater than that? Yes. It's greater than it, which means we need to get the overall total less, which again is done by decrementing the right pointer. So now -2 and 3 would be 1. Is that equal to, is 1 equal to this? No. Is 1 greater than it? No. Is it less than it? Yes. So we need to increment the left pointer. Okay, repeat the process. -1 plus 3 is 2, so we know our answer is there. We'll return, we take the indexes +1 because for whatever reason they want answers 1 index. But really the answer is 1, 3, right? The indices, which would really be 2, 4. That's all the problem is. Using 2 pointers and realizing that the array is sorted and what that means. So left, right equals the length minus 1. So we'd say, and because there's that, we know there's exactly one solution, we can really just say true, infinite loop, and just run. If this wasn't the case, we'd have to have more of a, I guess it really doesn't matter, we can do it either way. While left is less than right. It's less than right because they can't use the same number. If you use the same number, you can say equal. And that comes from this. You may not use the same element twice. So while we're still running, what we'll do is say if, we'll just say total equals, just to avoid having to write this, plus numbers right, we'd say if total equals target, we return left plus 1, right plus 1. Otherwise, if total is greater than target, so we want to decrement the right, else total is less than target, increment left. Delete, that's it. Solid.